Welcome to the Athfix. In this video, I am going to discuss about the Bayes theorem. It is one of an important mathematical machine learning concept that is used for the purpose of a classification. Here we gonna classify the objects into different classes. It was formulated by Thomas Bayes. Let's go with the definition. It is one of the machine learning techniques to create the classes or predict the classes with accuracy and precision. Its main applications we can see in the place of spam filtering, medical diagnosis, and the legal decision. What is exactly a spam filtering? In the email, you have a lot of different varieties of email. Some are spam, some are malicious, some are confidential, some are important, and some are related to the ads. Therefore, it is important for any app to segregate those all or make a classes of those all the emails, and for that purpose we can use the Bayes theorem. And in the medical diagnosis, there are different types of diseases, and some are tested positive or some are tested negative, and we need to find the probability of such diseases to calculate whether disease is present in this particular person or not. For that purpose we gonna use this Bayes theorem, and for the legal decision also we gonna use this particular name Bayes. Okay, fine. We go with the mathematical representation. In the mathematical representation, we're gonna use the conditional probability. If you don't know about the conditional probability, you can check out my previous video. Okay, here we have P of A bar B, or here P of A bar B can be represented as the conditional probability in which event A occurs if event B has already occurred, or occurrence of event A depends upon event B. That can be calculated using P of B bar A, in which P of B means occurrence of probability of occurrence of event B is dependent on event A, and we have P of A, that means probability of occurrence of event A, and we have P of B, that is probability of occurrence of B. Using this particular formula, we can able to predict predict the probability of a particular event happening. And this might be seen as a very easy formula, but it plays a major role while we are dealing with bigger versions of the Bayes theorem that we call as the naive Bayes. And we go with the total probability. If you don't know any sort of probability, or some of the probabilities are unknown while calculating the Bayes theorem, in such cases we can use the total probability to calculate such probabilities. For example, here P of A is unknown. We don't know what is P of A. In such case, if you know the value of P of B and P of A bar B, or conditional probability of A to B, in such case we can calculate the P of A. Here this is success rate, in which we don't have any failure. As I already discussed, there are complementary events. If we have P of B, then there is P of B dash, right? That means P of 1 minus P of B is equal to P of B dash. That is a complementary event. Here we are only considering successful events. Failure events are considered with the complementary events. Here we have P of A bar B into P of B, and we have to add P of A bar B dash and into P of B dash, right? If you consider these all things, then we can able to calculate P of A. And I am going to discuss this particular formula while discussing the problem, and it will give a conceptual clarity to this particular concept. Okay, we go with the problem. Given the example scenario, we have to apply the Bayes theorem to calculate or solve this particular problem. And what we have to find? We have to find the probability of occurrence of event A if event B has already occurred. For example, we have to find disease A given that the test gives a positive results, right? For example, whenever there is some disease, it has the two variations, like it might be positive or it might be negative. Positive means you have disease, negative means you don't have disease, right? And P of A represent how much of the population has the disease. 0.01% of the population has this particular disease. And we have P of B bar A, as I already given, is equal to 0.95, means 95% accuracy is there if there is a disease. If there is a if your test if we are able to conduct a test, then there is a disease, right? There is a disease, therefore we are conducting a test, therefore it would be 95%. And we don't know p of b they haven't given. In such case, as you know, we have the concept of total probability. We are given with p of a, we are given with p of b bar a. We have to calculate p of a bar b as mentioned in the problem, that probability of occurrence of a disease if tests are positive, right? And we have to calculate p of b because the formula goes like this: p of a bar b equal to p of b bar a into p of a into p of b, right? Here we don't know p of b. How to calculate? As I already discussed, p of b event can be calculated with the rest two of the values that are given. We know p of a, we know p of b bar a. As I already discussed, we have to add two of the events. Here this is a successful event, but we have failure event also, p of a dash and p of b bar a dash. And as you know, p of a it is 0.01 and p of b bar a is 0.95. Plus, what is p of a dash? If it can be also represented as 1 minus p of a. Here 1 minus 0.01 is equal to 0.99, and p of b bar a dash equal to 1 minus p of b bar a dash. Means we have to subtract 1 from this particular p of b bar a to get this particular value. Therefore 1 minus 0.95, we're gonna get it as a 0.05. After doing these all the things, we're gonna get our value as 0.059, and this is the value of p of b, right? Now we got our all the values. We have p of b, we have p of a, and we have p of b bar a. By calculating these all the things, we got our answer as 0.161. Means only if you convert this particular thing to in the percentage form, there is 16% of a population where their test become positive, means they have disease and their test become positive. Means there are 16% of peoples in the population whose tests are positive, and this is how we calculate the Bayes theorem, and we come up with a new Bayes theorem. As you already discussed, we are able to calculate the Bayes theorem for only single values. We don't have multiple values while calculating that. Therefore we recreated that formula in such a way that it can able to take multiple classes in it and multiple values, and it can able to make multiple classification tasks. For example, here we have set of the values. It can able to create such 4 set, right? We can able to achieve this using the new Bayes theorem. And the definition, it's a probabilistic algorithm that is used in the machine learning, and it works based on the Bayes theorem. And we can able to calculate the future events using the prior knowledge. Its definition is as same as the Bayes theorem, just the approach is quite different. And here we have the mathematical formula. X represent a set of features or attributes used for classification. It might be true or false. For example, I will go with the second. C, a set of classes or categories that we want to predict or classify instances into. For example, if your email can be classified as spam, malicious, confidential, and important, and ad related, right? These are the 5 categories. And X represent true, means if we say X here, okay, C bar X means probability of this particular C. If you have X, as you know, X is true or false. C equal to, if I add C equal to, I want to find the probability of emails being spam, therefore I add C equal to spam. Because I am adding, therefore I have to find X equal to true, means I have to calculate those all the probabilities in which getting a spam email is high, right? P of C means the probability of these classes, and P of X means those all the attribute true or false, right? Using these all things, we can able to calculate those all. Okay, fine. We have the types of neighbor classifier. See, when we have the data might be continuous or discrete in nature. Continuous in the sense, for example, the mobile signals, the radio signals, right? They are continuous in nature, whereas the data that is related to the GDP growth of a country, you can able to calculate the GDP growth of a country year by year. You cannot calculate it monthly, right? Therefore, this is a discrete data. For example, you got the data for 21 and 22 GDP growth of a country, and I want to calculate on 7th September 2021. Can we able to calculate that? No, because we don't have data. Such data is called as discrete data. And for the discrete data, we can use these two, the Bernoulli and the multinomial. And if you have continuous data like the signals are continuous in nature, you can able to find any sort of a value at any mode of time, you will get it. And for such data, we are gonna use the Gaussian. Gaussian is also termed as a normal, right? Bernoulli is gonna classify the objects into two types, true or false, and it might be yes or no, success or failure. It can be calculated using p of x equal to x, p of x 1 minus p. 1 minus p means the failure. This is success rate, this is failure rate, plus to 1 minus x. Using this thing, we can able to calculate whether it belongs to true class or false class. If the value of this particular thing is very low, then it is false. If it is very high, then it is true, right? Here we have the multinomial Bayes classifier. Multinomial means here we gonna consider multiple classes. Here we have two classes, true or false. Here we have the in the multinomial we have multiple classes. For example, spam and the malicious. The same email example. Here we can able to classify or categorize a particular probability into these all the classes. And we have the Gaussian, as I already discussed. If you have continuous data, the data that is continuous in nature, for such data we can able to use the Gaussian. And I'm going to discuss these all things in probability distribution, because these all the topics plays a major role in in that section. Okay, now I'm going to discuss the problems related to the naive Bayes. We are given with a data sheet that includes emails, and that emails are categorized into spam or not a spam. Here we have the first email, second email, third and fourth, fifth email, and those are categorized into spam or not a spam based on the words lottery and money. If both the words are present, like lottery and money both are present, then it is categorized into spam. If the email doesn't have the word lottery but has the word money, then it is categorized into spam. If it has the word lottery but doesn't have the word money, then it is categorized into not a spam. And if the email doesn't contain both the words, then it is categorized into not a spam. And here this is the data sheet, and we have to find the probability that email that I received is a spam, given that it contains the term lottery. If it contains the word lottery, then we have to calculate whether it is a spam email or not. Here we have to find out whether it is spam, therefore spam equal to 1, and for the word lottery equal to 1. Okay, for that we have p of lottery equal to 1, spam equal to 1 into probability of spam divided by probability of lottery equal to 1. Here the probability of lottery equal to 1 and spam equal to 1. Go here, and we have probability of lottery equal to 1 and spam equal to 1 is 1. And for this particular thing, we have some formula in the conditional probability that if you have p of a bar b, then it can be calculated as p of a intersection b divided by p of b. Here, what is p of a intersection b? The common things in both. This is 1 among 5, means we have 1 by 5. And how many spam emails are there? There are 2 spam emails among 5. Therefore 1 by 5 into 2 by 5 equal to 1 by 2. Here we have the value as 1 by 2. And how many spam emails are there? There are 2 spam emails among the 5. Therefore it is 2 by 5. And how many lottery words are there in emails, there are two lottery votes among the 5, therefore it become 2 by 5. Therefore there is a 50% chance that if your mail contains the word lottery, then there is 50% chance that it is a spam email. And this is how we gonna calculate whether a particular mail is spam or not. And this is all about the new Bayes. Well, do subscribe our channel for regular updates. Thank you.